Welcome to CS420, Lecture 17. In this lecture, we are going to be adding conditionals into our interpreter that we built in Lecture 15. So the first thing we'll do is we'll define our concrete syntax. This is how an expression should look. An if expression, they'll type the word if, put some sort of test expression, then the word then, some sort of expression to run when it's true, else, and some expression to run when it's false. Now you can download this interpreter from Canvas. If you click on the files, there's a folder called Interpreters, and you can download the interpreter for Lecture 15. After you download it and open it, you do have to put the hashtag lang EOPL on the top, and then you should be able to run it. And this is everything we did in Lecture 15. Now let's go ahead and add to our grammatical specification the new expression for an if. So there's going to be a new expression, and it'll start with the word if, and then we'll have some expression for the test case. Then we'll have the word then, and it'll have some expression for what to do when it's true, and then we'll have the word else and another expression on what to do when it's false, and we'll call this an if expression. So now that we have this added into our grammatical specification, we can run expressions with ifs in them, and they should be able to just parse. Now you notice the error that we're getting is this error, and that's because we don't handle the case of an if expression. So we do need to add that in, but we are parsing our if expression just fine. So we now have a new expression added to our eval expressions that will handle if expressions, and we'll get the test expression, the to expression, and the false expression out. Now we need to figure out how to implement this, and the first thing we have to do is determine what it means for something to be true. We don't have booleans in our language yet. So we can either add booleans into our language, or we can figure out some other way that is a true value and a false value. And what we'll do is we'll do what C does, and 0 will be false values and any other number will be true values. That way we can stick with just numbers as types and don't have to go through the trouble of adding booleans into our language. And just in case we want to change things in the future, we'll just have a little helper function that will give it one parameter, and it will return true if it's a true value and false if it's a not. So if it's not 0, if that one parameter is not 0, then it will return true. If it is 0, it will return false. And that'll be determine what's a true value and a false value in our if expressions. All right, so now we have to implement this, and the first thing we want to do is evaluate our test expression and figure out what's the result of executing that expression. So to do that, we just need to recurse and call eval expression on the test expression and pass in the environment. All right, so now that we've evaluated that, we want to know if that is a true value or not. So we'll go if true value. If the result of evaluating that expression is a true value, then we want to return what the result of evaluating this expression is. If it's a false value, then we want to return the result of evaluating that expression. So there we go. If this becomes a true value, then evaluate the true expression in the current environment. And if this returns false, then the bracket if will do this expression right here, and we'll return false. So now we should have a true or if expressions working in our language. All right, so let's test this, and we'll have two test cases. If 1, which is a true value, then we should return true. And if this would be 0, then we should return 3. So since this is a 1 and it's a true value, we should return true. And sure enough, it does. Now in this case right here, notice this expression does a little bit of math. So we got 3 minus 1 plus 2. So 1 plus 2 is 3. And then 3 minus 3 will be 0, which is a false value. So it should return the else part right here. So it should return 3. And that's what we get. And if we want, we can also put in a variable reference. We still have I, V, and X in our environment, so we could put V right there, and we get 5. Remember, in our initial environment, we have V being set equal to 5. And that was pretty easy. So let's add a way to declare new variables into our language. So we'll add let expressions. So let x equal 5, y equal 6, and then in this body. So x and y will be scoped to just the expression in the body. And to do that, we'll add a new expression into our grammar. So we'll go ahead and add that into our grammar specification and then do the implementation. So in our grammar specification, we add a new expression that begins with the word let. And then we have our expressions. I'll talk about that a little later. And then after those, we have the word in, and this is our body expression. So we have the word let. An arbitrary number of means we can have as many of these expressions as we want, like x equals 5, y equals 6, z equals 7, a equals 8, and so on. So we can have as many as we want, and that's what the arbitrary number of. And if you notice the parentheses around it, you kind of group that together. So we could go ahead and test this with scan and parse right here. So we have let x equal 5, y equal 7 in that body right there. And you can see that we have our abstract syntax tree. So we have one group called the IDs, which are the new variables that we want to declare. So that's one list. And then we have another list of expressions that we want to set equal to these. So we want to set x equal to the result of evaluating this expression. And we want to set y to the result of evaluating this expression. Then finally, this is our body expression. So in my eval expression, I now have a let expression, the case that we handle that, and it has the IDs, that's the x and the y that we want to declare. The rands, those are the expressions that we want to set them equal to, and then the body, which is the expression we want to run. So I'm just going to run this, and I'm going to show you what the IDs, the rands, and the body are just by returning that. So when I click run, and we'll go ahead and run this expression right here, the IDs are going to be the x and the y of the new variables we want to declare. Then let's go ahead and see what the rands are. Well, the rands is a list. Notice this parenthesis right there and that parenthesis right there. So this is a list with two expressions inside of it. And those are what we want to set equal to x and y respectively. And finally, we can see what the body is. And the body is this expression right here. It's a primap expression that's going to add x and y together. So now we know what the IDs, the rands, and the body are. So next, what we're going to do to implement this is we need to evaluate these rands and get their actual values back. So right now, there is an expression, a literal expression with 5, and a literal expression with 7. We need to actually execute that code. Because these expressions, right now, they're literal expressions, but if we want to, we can replace 7 with plus 5, 3. Or something like that. So we can put a more complicated expression in this spot. So now, instead of just returning the IDs, rands, and bodies, now I'll evaluate my rands in the current environment, and we'll see what we get back when we run something. So now, instead of being a literal expression and another literal expression, you can see that we have 5 and 7 back. And just to show you that this could get a little more complex, what if we added x, that one x that's been in our initial environment, that we included in our initial environment, equal to 10, plus 4. And let's go ahead and run this. And you could see that we no longer have this expression, x a prim-map expression that adds 4 and x together, we actually have the result of evaluating that in our list. By the way, evalRands is a function that we wrote when we implemented our prim-map expressions that take in a list of expressions and evaluates them and returns the value back with this map. And remember, we call evalRand that eventually just calls eval expression. All right, so what I'm going to do is take that list, the 5 and 7, if we're running this expression, or the 5 and 14, if we're running that. We're going to take that and we're going to just name it args. We're going to use let to do that. Now, don't be confused. We're not using let to implement this let. We're just using let to be able to give us a variable. This kind of stores some intermediate result. So args will just be the 5 and 7. Now I'm going to take my environment and extend it with some new variables. Remember, the IDs are x and y, and the args now are the result of evaluating our expression. So we're going to extend our current environment with new variable names and new values that they're equal to. So let's go ahead and run that and see what we get. Okay. So now if you notice, we have the IV and X, or the 1, 5, and 10 that we had before, but now you can see that we have two new variables, X and Y, added onto its environment. So now that we've extended our environment with the new variable names and values, we can just evaluate our body in that new extended environment. So now we got our final answer back. So we got x, which is 10, plus 4, that's 14. And then, so y is equal to 14, and x is equal to 5. So 5 plus 14 is 19. Now this might be a little bit confusing as well. But this, how come this x isn't equal to 5? Why is it equal to 10? Well, when we evaluated this operand, we hadn't extended our environment with the new variables that we're declaring. So this x refers to the x in our initial environment because this x has not been created yet when we run this code. Now, if you remember learning Racket, that there is the sequential binding let that will extend our environment here, and then it will extend it one more time. That way this can run in an environment that already has x declared in it. But that's how we implement the let expression. And I just want to make sure that we're not using this let to implement our let like we did with if. We're using Racket's if to kind of implement our if. We're just letting let keep this a little simple. What we could do is just take this out and put it right there, and then we won't need the let at all, and we get the same thing. Let just kind of allows us to simplify that expression by giving something a name. So that's the same thing, and it should work in the same way.